Hey Gripboard, Rich here, and I'm back talking about the Circus Pinch. If you follow the video already, you learned I took my son's Legos and I designed what is probably a better dynamic pinch gripping device. It's progressively loaded. I used my son's Legos and I built the first prototype. Well, congratulations, we have our first prototype built in metal by Adam. Adam, thanks for making a reality of this. And Adam inspired me. He took my simple idea and he built it like literally within 6 days of seeing the damn thing. And it works. And we were talking about doing some dimensional changes. Well, Adam inspired me to build one too. I don't have a metal shop, so I took my Teddings telegraph key. This is Warren Teddings Titan's telegraph key. I took the bottom part and I got rid of the top and I just slapped some wood together. You'll see one small change here from Adam's and my original design is I got rid of half of the parallelogram. The part that kept the weight traveling straight up and down, I removed. So I got rid of a chunk of steel that would have gone here. I got rid of a hinge point here and a hinge point there. So my theory was it'll reduce some of the friction. So now the weight is going to travel in that seesaw motion like the Titan telegraph key. But the important part is the thumb platform will still travel straight up and down. And that's what we really want. You can see how tight I can get it. I was able to use one little piece of metal, everything else is wood. There's a little bit of flex here because I don't have any of these bolts tightened down, and you'll see why in a second. So, again, I got rid of the second half of the parallelogram, but we still have the parallelogram here. So, again, the Circus Pinch is still a Circus Pinch. It's kind of maybe a half Circus Pinch from when I originally designed it because the weights aren't traveling straight up and down like we originally did, and the version that Adam already has built. But the important part is here, and we're still traveling straight up and down. Well, I'm going to blow your minds here. I've come up with yet another idea. You ready for it? Okay. Check this out. What happens if we get rid of the parallelogram? Check that out. We're still traveling straight up and down. What happened? Why is this different? Why is this different than Titan telegraph key? Well, what it is we've raised the arm. The telegraph key, the arm is down here. By raising that arm, we're working the bottom half of the arc. And our thumb, by having this thing hinge, it's able to, our thumb's going to keep it level. And again, we're getting that perfect close at the end. So, I'm calling this now something different. I'm calling this now the Circus Pinch. The reason I'm doing that is I'm going to refer to this part here as the trapeze. So again, we have the fulcrum point, same as before, only now this is swinging on the trapeze because we got rid of the parallelogram. The Circus Pinch is removed. We now have the Circus Pinch. We're able to go straight up and down. So part of the idea here, I got to thank a guy named Aaron. Aaron gave me the idea for something that really improved on this idea. Aaron had said use something round for the thumb part. Rather than the flat, Aaron said use something round. Well, taking the trapeze idea to the next level, check it out. We can use different diameters to achieve different results. So I'm just going to grab one of them here to give you an idea. This is under an inch. This is maybe 3/4 of an inch tube. So again, bear with me. I'm doing this with one hand. I remove our flat platform or our flat trapeze, and I'm going to install this round one. I'm using nails. Obviously, when we're doing this for real, we want these things bolted in. Okay, so check this out. Again, I got this idea from Aaron to use something round. We still have the trapeze effect, right? So if I grab from two hands from the sides, we still can work that range with the two-hand motion, right? If you take one hand and work it in the center, Now, when we make it for real, we might want to expand this distance between these two arms so you big guys can fit in here. But check this thing out. Again, the hinge can happen, but it still can travel up and down. But check this out. Imagine if this wood was gone and that was metal. Imagine that pipe was welded on so that it literally is able to touch metal to metal. From the closed position, I can now slide my thumb in and out. And I'm working a whole new range of motion. It's kind of like a dynamic isometric because I can't travel down really any further, but I can push in and out. I'm working right now. This hurts. This is only 2.5 pounds. It's a 2-to-1 ratio here. But I'll tell you what, it's a whole new dynamic range. It's a whole new level of thumb pinch training. We can still do everything that we wanted to do by using something like that. We can stay the parallelogram, or we can take it out and let it be a trapeze. But once you go into something round, the whole thing changes because you're able to start really pulling it into your hand or pushing it away from you. Now, if you had a series of holes on this piece, a series of holes there, actually, as a matter of fact, if you build the whole thing with perforated steel, it would give you all the different ranges you want to move it. You could basically make this a one-size-fits-all apparatus where you start training with it, you start customizing it how it fits your hand. So if you're a big hand guy, you're going to want your fulcrum point to maybe be a little bit higher, okay? If you're a smaller hand guy like me, you'll probably move this thing down. Mine right now is set for 7 inches, and that would be 7 inches from the base of this platform. Now, part of the reason why I'm calling this here the Circus Pinch is, in the ideal world, you will not have this permanently affixed. In an ideal world, this also will be removable. So that, I call this the tongue. When you grab onto this, the tongue. In an ideal world, we'd have a couple different kind of tongues, depending on how you want to train. Maybe this should be more rounded for that one hand, or so you can kind of reach around. I know Adam has already thrown out the idea of making a thick bar style trainer. Now that I've come up with this idea of being able to drag this back and forth, you know, I think there's going to be some experimentation going on. I think you guys are going to come up with some good ideas. So the idea here is it's time to start thinking outside of the box. So here we go, gentlemen. I'm going to give my final shout out. I have a special gripper here. Aaron gave me the idea to go round, and Aaron made me that gripper. And that was a prize that I got from this gentleman's SJ3 competition. He had a Who Can Write the Best Write-Up contest, and I won it. So thanks, guys. Thank you, Aaron. And thank you, Nate. And thank you, Adam, for inspiring me to actually try to build one. So I know Adam wants to know about dimensions. So my version, the arm part, which would be here to here, it's about 5¼ inches. So in millimeter land, that's about 1/34. The total length of the arm from the fulcrum point to there, it's about a 2.5 ratio, so it's about 334 millimeters. Yeah, I think this here, we're looking at it, boys, the Circus Pinch. We're looking at the better dynamic pinch grip device. I think once somebody starts building these, I think this is going to be the way we're all going to want to train for a while. Good luck, everybody. Thank you.